Okay, hi everyone. I want to share with you what I call my infinity speech. I share this with almost every class that I teach here because at some point in time it comes up in discussion here. I just want to talk a little bit about the nature of infinity. Now, we're not going to go very far into this, but we're going to go a little bit into it. Let's just say to start off with that you were to go to a library that had an infinite number of books in it. Okay? And you decided that you were going to go and take out all of the books, okay? You had quite a night of reading planned, so you're going to take out all of the books. You threw them in a wheelbarrow, out you went. How many books would be left in the library? Well, none. None, okay? We'd have no books left out in the library, okay? But let's say that you went in and you were a little bit less ambitious and you went into the library that had an infinite number of books and you decided, you know what? I'm only going to take out all of the even-numbered books. Well, let's just think about that. How many even numbers are there? Well, it turns out there's an infinite number of even numbers, but that would still leave you with all of the odd-numbered books in the library, which would mean that there's still an infinite number left here. So we can see that infinity minus infinity, well, could be 0. Infinity minus infinity could still be infinity. This is one of the interesting things about infinity, and why it really doesn't count as like a real number. Because if you've got an infinite number of items here, then what's characteristic of an infinite set is that a proper subset of that set could still be the same size as the original set. Now, to just illustrate that I'm not just kind of making that up here, let's just say, for instance, that we did have all of the infinite. So here's the set of all the books in the library, and they're numbered 1, 2, 3, 4, and so on, out to infinity. If you took all of the even-numbered books, that would be 2, 4, 6, 8, and so on. See, the thing is, you can take every book that you signed out and map it directly to one of the numbers, one of the natural numbers, and this can go on forever. So the size of this set has got to be the same as the size of the original set, which is kind of a bizarre concept, okay? Which is why Garrick Cantor, when he first came up with his method of analyzing infinite sets and whatnot, didn't meet with a lot of success at first. He couldn't seem to convince a lot of people that he was saying that what he was saying was correct. A lot of people really judged him, and it really made him feel bad about himself. Anyway, this leads us to another kind of a neat situation, something called Hilbert's Hotel. Let's say that you got a hotel, okay, and you've got an infinite number of rooms in it, goes on and on like that, and let's say that they're full. Okay, the whole hotel is full. So here you come along, and you need a place to stay. So is there room for you in the hotel? Well, the answer actually is yes. Because what we got to do here is, maybe what we'll do is we'll get the hotel owner here to send out a mass text to everybody saying, please, could everybody just exit your room, move one room over. So everybody comes out and moves one over. This person moves there, this person moves there, this person moves there, and so on. And everybody does this, okay? All the infinite number of people here do this. And what that does is that opens up this room right here, and you can go in, okay? Which means that infinity plus 1 is just infinity, okay? Now that's an important result. And the reason why I give this speech every year, because I want students to know something here. You always hear about this. Everybody does it. Everybody gets involved in this little debate at some point in time, where there'll be the two of you, you and your friend, and you'll be first you're playing, and then all of a sudden you're arguing, and it goes something like this. I'm smarter than you. Oh yeah? Well, no way. I'm 10 times smarter than you. Well, I'm 100 times smarter than you. Oh, I'm 1,000 times smarter. And then the numbers go up, and then eventually someone always says, well, I'm infinity times smarter than you. The next person invariably says the same thing. Oh yeah? Well, I'm infinity plus 1 smarter than you. Well, that kid loses. That kid loses because that's only infinity, and the other person already said that. Okay? Now, so let's talk about this little fight that you're having with your friend here. Let's say that you are involved in this, that you see it happening, And you know better. You know, man, I got to get to infinity first. Now let's say that your friend gets to infinity first. Okay? Haha, I'm infinity times smarter than you. Now, if you really want to win this little fight here, well, there's two ways to go about this. One way is to say, oh yeah, I'm infinity minus 1 times smarter than you. Now, what should happen there is it should cause your friend to look at you kind of funny and think, well, that was a dumb thing for you to say. But you see, when they do that, deep in your heart, you'll know that you've won, because you know infinity minus 1 is just infinity. Now, you haven't really said that you're smarter than them, but when you look at their confusion, you'll know deep in your heart that, yes, you are smarter than them. Or, we can go about doing this. Okay? Infinity. Actually, before we talk about this, let's just go back a little bit and talk about sets of numbers. Let's say that you've got a set that's got 2 numbers in it. Okay? What I want to do here is we're going to take a quick look at how many subsets we can create out of just those 2 numbers. Okay, so if you've got 2 numbers, I could create a subset that's got both of those numbers in it. I could create a set that's got just the 1. I could create a set that's got just the 2. Or I could throw down there the empty set. Okay? But I can see from that I've got four different sets that I can pull out of that set of 2 numbers there. Now, let's say that I've got 3 numbers. Okay? 1, 2, 3. Let's talk about all the subsets of that set that you can create. Well, I could have all 3 of them. Whoops. Or I could have just 2 of them, which leaves me with 1, 2, 1, 3, 2, 3. Or I could have singles. I could have the 1, the 2, or the 3. Or finally, whoops, sorry, I was just about to put a 0 there for the empty set. But the empty set has nothing in it. But I could also have the empty set out of that. And I notice that there are 8 different subsets that I can create. Okay, now what this tells me, and it's actually easy to verify, but don't really have time for that right now. But that means that if you've got a set, okay, that's let's say that you've got a whole bunch of different values in here, and you've got, here's set A, and let's say the number of values in A is x, then the number of subsets will be 2 to the x. Okay, and notice that right away, when you've got, even if you've got 2 numbers in a set, even if you've only got 1 number in a set, if you've got 1 number in a set, there are still 2 subsets you can get, that number by itself or the empty set, that the number of subsets of a set is always larger than the number of items or elements of the set. Always. So what we know here is that if I create another set of all of the subsets of the original set, okay, and I know that's maybe a little bit confusing, but that group of subsets will always be larger than that original set. Now, that's an interesting point here, and I'm not going to go through trying to prove any of that, just kind of take my word for it. But what that means now is, what happens if I've got a set of the natural numbers, all of them? Well, if I create a, now let's look at how many numbers are there? Well, there should be, okay, if we call this set A, the number of elements in set A, well, that should be infinite, okay? But the number of subsets of that set, I know, should be 2 to the infinity. And we've already commented that the number of subsets should be larger than the original number of values in that set. So I know that 2 to the infinity must be larger than infinity. So this is a weird sort of result here. This isn't like that infinity plus 1 being infinity again. This is now quite legitimately another order of infinity. So turns out this number is substantially larger than that infinity. Now that might seem a little bit weird, but it turns out there are orders of infinity, and the one that we normally associate, or the number that we normally think about, okay, is the smallest type of infinity, what we call the countable infinity. Okay, countable, because what we do here, if we've got an infinite number of objects here, we just simply line them up or map them to the different numbers in the set of natural numbers here. So that is kind of weird. Now I'm not really using the appropriate symbols here, but just so that you get the point here. So 2 to the infinity is a number that's larger than this regular infinity, and actually we're going to call it C. Okay, C to stand for continuum. And C, it turns out, and again, I'm offering a lot of this without a lot of proof here, but C turns out to be the number of numbers, if you will, between 0 and 1. Okay, which, when you think about it, that's an enormous number. It's a mind-boggling number. The numbers here between 0 and 1 are called dense. Okay, the real numbers in between there are dense. There's so many of them. You could never like throw a dart on there and hit a spot in between 0 and 1 where there wasn't a number. Okay, so now let's say that you're having that little fight, your friend beats you to infinity. Well, you can just say, I'm smarter than you, C. And you win. Now, you hope you win, because it turns out if C is the size of the set of subsets of the natural numbers, well, then the set of subsets of a set that's got what we would call a cardinality. Okay, cardinality means the number of elements in, okay, the size of the group. Well, you want to hope that your friend isn't somewhat familiar with transfinite mathematics, because they might say 2 to the C. Ah, but if you're really clever, you might say, oh yeah, I'm smarter than you 2 to the 2 to the C. In which case that person would respond with, I'm smarter than you 2 to the 2 to the 2 to the C. And how long can that go on? Forever. Anyway, I hope that was entertaining, and I hope now at least you'll never lose that fight. Bye.